Okay, so here we are, section 1.2. We're talking about quadratic equations. And a quadratic equation has the form ax squared plus bx plus c equals 0, where a, b, and c are real numbers. That means that they are integers in a way, 1, 2, 3, 4, negative, whatever we want to talk about. And they have something to the second power. So that's the key here, is to realize that you always have to have one of your terms has to be to the second power. So here's a couple of examples of quadratic equations. You got x squared minus 2x minus 8 equals 0. You've got 3x plus 10 is 4x squared. They're both quadratic equations. One is in the proper format, which is this one. This one is not. So one thing we always have to make sure we do is to have it in this format where the equation is set equal to 0. So there are four methods we're going to look at for solving quadratic equations. We're going to look at factoring, the square root method, completing the square, and we'll get to that at another time, and using the quadratic formula. So let's first look at to solve by factoring. Now, we have to use what's called the zero product property to solve for x. And the zero product property tells us that if we have two numbers multiplied together equals 0, that's only true if a is 0 or b is 0. So basically, when you have two numbers multiplied together equals 0, one of them's got to be 0. And again, this product only works if the equation is set equal to 0. So before we actually get started on the solving part, let's look at some factoring examples. You know, factoring is a concept where many people have trouble with. So in order to solve an equation by factoring, you have to understand how to factor. So when I look at factoring any polynomial, especially quadratics, we want to look at two numbers multiplied together to equal this number. So the way I always do it is I first, if there's not a greatest common factor, I set up my two sets of parentheses. Now, when this number here is a 1, in other words, we have a 1x squared, we automatically know that those first terms in each parentheses are both an x. The way we determine what numbers go here and here, again, when this is a 1, is to look at factors of positive 6 that add up to be a positive 5. And in this case, that's a plus 3 and a plus 2. How do I know I'm right? Well, I know x times x is x squared. I know 3 times 2 is 6. I check my outer terms, which is 2x, my inner terms, which is positive 3x, and that gives me 5x. So that's how I know that I factored correctly. Always check using your FOIL method. That's how you always can check. So I would have my first terms are x squared, my outer terms are 2x, my inner terms are 3x, and my last terms are 6. And when I multiply two numbers together, I get the product that is the number I started with. That's how factors always work. 2 times 3 is 6, 3 times 5 is 15, so on and so forth. Okay, if I want to factor this next trinomial, I notice here that I've got -2 and -8. I still have x squared, so I know automatically that that's x times x. Since this is negative, I need a positive and a negative here. So therefore, my factors of the -8 itself, one's positive, one's negative. That's the only way I can get a negative 8. And when I add those together, they got to have a difference of -2. So if I think about factors of 8 with a difference of 2, I know 4 times 2 is 8. since I have to have a -2, I know the larger value has to be the -4. So again, you can check your factors using the FOIL method. X times x is x squared. 2 times x is 2x. -4 times x is -4x. -4 times 2 is -8. Combine these to get x squared minus 2x minus 8. So, if you're not sure how to factor, always remember you can check them. And that might also help you understand what you're doing wrong if you're not getting them correct. The third factor, trinomial we're going to factor, is x squared minus 7x plus 12. Again, I've got an x here, so I know this is an x and this is an x. I need a positive 12 as the product of these two numbers, but I need a sum of -7 with my factors. So therefore, I'm thinking of two numbers that multiply together to give me a positive 12 that also add up to be a -7. And since we have a positive 12 as this product here, both of these have to be negative. And -3x and -4x is -7x. So, that's what you've got to do to factor. Because in order to solve by factoring, you have to know how to factor. So let's look at a first example here, where I have x squared plus 5x is 24. In order to solve by factoring, we have to make sure that this equation equals 0. So what I'm going to do first is I'm going to subtract 24 from both sides. Simplifying, I get x squared plus 5x minus 24 is 0. Now I factor the left side. Since that first term is a 1x squared, then I can just look at this, and x times x is x squared. Now I look at factors of -24. This time the factors have to have a difference of positive 5. Remember, since this is negative, I have to have a positive and a negative. So if I think of two numbers that multiply together to give me 24 with a difference of 5, that's going to be an 8 and a 3. I need a positive 5x, so I know the 8 is positive and the 3 is negative. So that's the factoring portion. Now we've got to solve using that zero product property. So what I know is x plus 8 is 0, or x minus 3 is 0. So I solve each of these equations. What I do is I subtract 8 from both sides here, and I get x is -8. I add 3 to both sides here, and so x is positive 3. So those are my two solutions. And you can always check by going back to the original equation. Let's move on to the next example. I have x squared minus 9x plus 20 is 0. So again, this one is already set equal to 0, so I can skip right to the factoring portion. Since that's a 1x squared, I have x times x. That's a positive 20. -9 here, so therefore I need two numbers that multiply together to give me positive 20 that add up to be -9, and that is a -4 and a -5. Think about it. -4 times -5 is 20. -4x plus -5x is -9x. Then I use my zero product property. Add 4 to both sides here. Simplify to get x equals 4. Or add 5 to both sides here. Whoops, run out of room. And so x equals 5. So those are your two solutions to that one. Okay. Factoring just takes practice. So practice till you get it right. The next method we're going to talk about is the square root method. So, suppose we have an equation in a form where you just have one term squared equals a number, or you have another term that is inside parentheses, still squared, equal to a value. This value cannot be negative. We can solve these types of equations using the square root method. The way we use the square root method is if we are given something squared equals another value, then we can say that our x is the square root of that value or minus the square root of that value. Same thing works if you have a term inside parentheses squared. So the term inside parentheses is equal to the positive square root or the negative square root of what that value is. So if I look at x squared is 16, then I know using the square root method that x is the square root of 16 or x is minus the square root of 16. I'm just following this rule right here. I go from this step to this step. Take the square root of 16 to get 4 or negative square root of 4. Okay? And oftentimes we just, instead of doing this, we can say x is plus or minus the square root of 16. So x is plus or minus the 4. Okay, so either way is fine. It doesn't have to be, you can do it this way or you can do the plus or minus. Looking at this equation here, this one looks very similar to this right here. So I am just going to follow this rule the way it's set up. So if I have x minus 2 squared is 9, I know that x minus 2 is the square root of 9, or x minus 2 is minus the square root of 9. Don't forget, our negative sign is not under the square root. It's on the outside. Take the square root of 9 to get 3. Take the square root of minus the square root of 9 here to get negative 3. Solve for x by adding 2 to both sides here. So x is 5. Add 2 over here. Be careful with your signs. So my solutions for this one are positive 5 or negative 1. And again, you can always check. If I substitute 5 up into here, 5 minus 2 is 3. 3 squared is 9. If I substitute negative 1 up into here, negative 1 minus 2 is negative 3. Negative 3 squared is also 9. So just, when we're doing the square root method, simply follow the rules in front of you. Most rules in math are what we have with if-then statements. If this is true, then I can do this. Okay? If this is what I have, then I can write it as that. And again, you can always do plus or minus if you choose. Okay? So this is the simplest way to do it as far as breaking things up. You can do it more complicated if you want. All right, so that's the second method we can use to solve a quadratic equation that we're going to talk about today. The next method is using the quadratic formula. Now, the one thing about the quadratic formula is this method will work for any quadratic equation, whereas factoring and square root method both have their limitations. Not every polynomial can be factored. Not every polynomial can be done using the square root method. So the quadratic formula is one that works for any quadratic equation. But the problem with it is it's a messy formula, and you've got lots of operations that you have to be careful with. As far as squaring, subtracting, multiplying, lots of problems. So, Even though it only deals with numbers, the formula can be a little tricky, and oftentimes it takes longer to do this than factoring or using the square root method, but it's, it's your call. Just some breakdowns. Your quadratic formula, your value for x equals, and you see all of this is in the numerator, minus the b. So that's minus whatever sign b is, plus or minus. That's kind of like where we get these plus or minuses up here. The square root of b squared minus 4ac all divided by 2a. This b squared minus 4ac is called the discriminant. It's just a name for what's underneath the square root. And keep in mind, to be able to take the square root, we do must be positive. We don't do imaginary numbers, so we're looking for positive values. And what we know is, if we do this b squared minus 4ac part and it is greater than 0, then we have two real solutions. If this number, once we evaluate it, equals 0, we have one real solution. And if it's less than 0, which means that that's a negative under a square root, we have no real solution. And again, as we did before, the equation must be set equal to 0 before you can use the quadratic formula. So let's look at a few examples of that. So if I look at this first example, I want to solve 3x squared minus 5x minus 1 equals 0 using the quadratic formula. First thing I do, I identify that a is 3, b is negative 5, and c is negative 1. I write down my quadratic formula. I write it big too. I don't want to make it too small or I won't be able to see anything going on here. So once I have my formula, then I substitute my values. So I've got minus b. Well, b is negative 5. So this is going to be minus negative 5 plus or minus negative 5 squared minus 4 times 3 times negative 1, and everything in the numerator is over 2 times a. What you've got to do is you've got to be able to get what this number is. Don't worry about the square root yet. You've got to be able to use your calculator to be able to get this value. If you enter without the square root these numbers exactly as they appear, you should have no trouble. You've got to make sure when you're squaring something to put it inside parentheses with the square on the outside to make sure that you end up getting a positive value here, because negative 5 squared is 25. So if I simplify this formula, this right here becomes a positive 5. Underneath this square root, and if you're doing this on your calculator, you can pause the video to make sure you get it correctly, but this becomes 25, and this becomes a positive 12, which gives me 37, all over 2 times 3, which is 6. So we still have two solutions here. In the back of your book, there possibly will leave it as just plus and minus, but we do have two solutions. We have 5 plus the square root of 37 over 6, and 5 minus the square root of 37 over 6. 37 has no perfect square factors, so therefore we don't need to factor it further. So this is our answer right now that is good enough. It's simplified as far as we're going to take it. My next example, I've got 4x squared equals negative 12x minus 9. What I want to do here is, again, to use the quadratic formula or to factor, either one we choose to do here. We need to make sure the equation is set equal to 0. So first I'm going to add 12x to both sides. Simplify to leave me 4x squared plus 12x is negative 9. Got to bring that negative 9 over to the other side. So I'm going to add 9 to both sides. So now I've got my equation in the proper format. I know that A is 4, B is 12, and C is 9. Okay. Using the quadratic formula, I've got x is minus b plus or minus b squared minus 4ac, everything over 2a. Now I substitute. Then I simplify. So, as you are simplifying under here, 12 squared is 144. Negative 4 times 9 is negative 144. So we end up with the square root of 0. Well, the square root of 0 is just 0. So that, in this case, leaves us with only one solution. So that's the case where the discriminant is 0. We only have one solution, and it's negative 12 over 8, which reduces down to negative 3/2. Okay. Last equation we're going to look at for today is the x squared plus 2x plus 2 is 0. It's set equal to 0. So we don't need to do anything there. So I identify my A, B, and C. Write down my quadratic formula. Then I substitute. So it's minus b plus or minus b squared minus 4 times a times c all over 2a. Simplify in here, and what I end up with is, when I simplify this, that's 4 minus 8, which is negative 4. I can stop. There is no real solution because you have a negative under the square root. So at this point we will finish. Nothing else to do here. We are not covering imaginary numbers. So if you ever get a negative under a square root, don't immediately think you're wrong. Just check your math. Check your arithmetic here just to make sure that you know your positives and negatives are right, and just you're done. So that's all for quadratic equations. We will pick up with this on class. We will do more examples of all, and have some time for some help if you need it.